we like to continue. So I think the next presenter comes from LONGi. We have with us Jason Yan, the Senior Product Marketing Manager for LONGi, and Jason will tell us more about LONGi's way of smart soldering for advanced solar modules. Jason, the floor is yours.
Hello, how are you?
Everything fine, yeah. How are you?
Yeah, I'm good, very good. So I'm very honored here to give a speech representing for LONGi. So maybe can we start here?
Please share your screen. And
okay. Hello everyone, this is Jason Yan from marketing department of LONGi. So today my topic is about smart soldering, the reliable model technology ensuring best customer value. Basically, my presentation will include 4 parts. The first one is the analysis of product value, and second one is the product development direction, and third part is the smart soldering and ensuring best customer value. And the last one is LONGi's reliable bifacial model. So as we can see, LONGi's colleague talk more about the BOS course and the LCOE. So from my point of view, I will talk in another direction, probably in terms of reliability. So the first part, I will talk about analysis of product value. As mentioned before, so you can see the lower LCOE means higher product value. So when we do analysis on the LCOE, we can find that firstly, we need to ensure the stability of a supplier and the system and the model. And secondly, we can pursue maybe a lower both cost and model cost. And finally, we can get a lower LCOE. So basically, be reliable is the foundation and economic is the target. And since we install our models into our PV power plants, so the PV system design, it's very important for our models design. Actually, it concludes 3 parts, which is we need sustainable, reliable, and economic. So from the sustainable point of view, we need our models generate more energy yield. So that means we can adopt the bifacial technology, and we can use lower irradiance performance and lower temperature coefficient, lower LID, LVTID, etc. And from the reliability point of view, we need our products O&M security. So that means the O&M friendly and make sure our product long-term stable and mechanical and electrical safety. And lastly, from the economic point of view, we want our product save the both cost, means lower capex. So that means high efficiency mode, as William Chu mentioned last presentation. And also, we need to have a reasonable electrical and structural design for a better LCOE. So based on the system design, we can find what is the product development idea, which is the economic and reliable. So basically, from the economic point of view, we can have 3 approaches. Firstly, we can get a high utilization of light, which means we can produce more power. And secondly, we need to have a reasonable electric design, maybe a not so big motor current. And lastly, we can have the high density packing, which means the high efficiency power. And from the reliability point of view, we need our reliable products. For example, we need a lower PID and lower LID and LETID. And secondly, we need a reliable supplier. Actually, this is very important. For example, last year, again, the glass price goes up crazy. So maybe it increased about 60 to 70%. That give us more pressure on the manufacturing. So, and lastly, for the reliability, we must make sure the transportation is reliable. So next part, I will talk about the product development direction in detail, basically in six dimensions. So the first one is from the high value point of view. We want get a higher utilization of light. Absolutely, we can use the bifacial technology. That means more energy generated by scattered and reflected light, and bring more value to customer. Basically, we have promoted the bifacial model since 2017, and because it can bring more value to customer, and we have built many pilot projects all over the world, from India, Europe, and to USA and China, and it is well recognized by customer. Until now, we have shipped over 10 gigawatts bifacial model, so which is #1 in the world. Secondly, for higher utilization of light, actually we can adopting texture ribbon for the improving incident light utilization. This is for a better understanding. Actually, I draw 4 sketch for the different ribbons. In the left-hand side, the first one is a traditional flat ribbon. So actually, you guys can see when the light incident on the ribbons, the light will reflect out totally. So that means no utilization of this light. And the second one is the light reflective ribbon. So this is probably used, I think is 2016 or 2017. The mechanism of this technology is total reflection. And you can see when the light incident on the ribbon, it will reflect to the glass, and then will from the glass to the cell. So it's a secondary utilization of light, which means the glass and EVA will absorb light. And third one actually is most popular here recently. It's a circular ribbon. It's combination of primary and secondary reflection. However, the glass and the EVA will also absorb light, and some light will escape. And the last one actually is the technology we are adopting now. Actually, is the texture ribbon. The main mechanism is the primary reflection. That means the highest utilization of light you can see from the figure. And from the economic point of view, and we also need to have a reasonable electric design. So the motor current is not the bigger the better. It's important to consider the balance of economic and reliability. For example, when we compare 2 different motors with the same cell efficiency and 22.76%, with one motor current is around 14 amps, and another one 220 is the motor current is 18.4 amps, and we did some analysis on the power loss. So we can see the main difference is the ribbon loss and the connect loss, simply because of the higher current means higher loss. So actually, when we compare the power loss, we can see for the 14 amps motor, the power loss is 0.1%. However, for the 18.4 amps motor, the power loss is 1.6%. That means much more power loss. So the motor current is not bigger the better. And from the system's point of view, we also do analysis on the cable cost. As mentioned, I mentioned before from Jinko, there is some analysis on the cable cost, recent cost. So I think my conclusion is very similar to them. You can see in the left-hand side, the figure, it shows also the cable cost will decrease with the increase of the bifacial motor current. However, the resistance cost will increase. So we needed to get optimum motor current. So that means we did a calculation for 3 different motor current and find out that if the motor current is around 14 amps, the total cost will be the lowest, which is 0.51 cents per watt. And another technology I talk about is the high density packing. So actually, this is the 3 different technology. The first one from left-hand side is a normal gap. Actually, basically, it's around 2 millimeters gap, and the middle one is a small gap. It's very popular recently. So it's around, the gap is around 0.6 millimeters. So when we compare these 2 different technology, we can see the small gap technology can have a high efficiency. It's about 0.18% higher, and the BOM cost is lower. The power, of course, is very similar. And when we compare the Taiyan technology, also the efficiency is highest. It's about 0.24% higher than normal gap. However, the BOM cost and the power will be lower. We did some experiments. The power decrease will be 5 watts to 10 watts. So so we choose the small gap technology, considering the motor power, efficiency, and the BOM cost. And from the reliability point of view, we need a reasonable product structure. So motor size should be designed carefully. Increasing motor size will increase the stress of materials, especially when the motor width increase. So in the left-hand side is a typical figure, shows the deformation of 182 72 cell motor in 3,1600 par pressure, and actually the maximum deformation is in the middle of the motor. It's around 30 millimeters. And then we did some comparison about the 182 motors and 210 motors, because the width is different. For the 182, the width is 1133 millimeters, and for the 210, the width is 3003 millimeters. So you can see in the red line is the deformation. It's about when the width increase to 1330, the deformation will increase 40%. And the black one and orange one is for the frame stress. And we can see when the width of the motor increase to 3003 millimeters, the frame stress will increase 30% to 70%. So that means a higher risk. And for reliability, we also need to reliable energy yield. So reliable products makes long-term energy yield stable. Actually, it can include in 4 parts: the PID, and we want to improve the anti-PID property. That means we can adopting a high volume resistance POE and optimize the encapsulating process. And for the motor working temperature, we need reduce the working temperature. So in this side, we can use low thermal resistance material and use high efficient motor. And for the LID and LETID, we can adopt the gallium dope wafer, high quality wafer, some advanced passivated process, excellent annealing process. And another important factors is a supplier. So the feasibility of the maturity of the key material will affect the reliability of products. For example, is a glass supply, one of the key boundary conditions correlating to motor size. And we did some analysis on the capacity of 2 different size glass. So for the 11 millimeters glass, the capacity actually is double than the 13 millimeters glass. So that means the wider glass, the weaker supplier. And in the right hand side is actually we did some experiments on the bending test for the 15 millimeters wide glass. So we can see for the 4 different suppliers, the temperature property have a big difference. So the technology maturity has reached the limit when the width of the glass is 15 millimeters. And another important factor is the shipment feasibility. So our traditional transportation is the landscape package. So it is widely used and verified for many years. It's mature and reliable. And one limiting factor is, I think, is 40 high cube shipment container. So the door height is 2570, and when we minus the 100 margin and minus 105 pallet tours, and we can get the optimal motor width is 1130 millimeters around. And so when the motor width is bigger than 1130, that means we cannot package our motors in the container. We can only change the package to, I think, is a portrait in the left hand side, or it's a flat package, and then your right hand side is the motor must be a portrait package. So all of these 2 different package will increase the risk of falling and micro crack and breakage. And third part, I will talk about the smart soldering technology ensure best customer value. So basically, considering all of these 6 production direction I mentioned before, so that's why we promoted the M10 HIMO 5 model. It's a technology integration of M10 gallium doped mono wafer and use high density packing and segmenting the ribbons, which can get a high efficiency and high reliability. And lastly, we use the reasonable 72C model design. It's very classical and is reliable. So I will talk about more about smart soldering. So what is smart soldering? Actually, it includes 2 technology, working in tandem. It's segmented ribbons and a small gap. the triangular section ribbon can maximize the use of sunlight, and the flat section can achieve dense soldering with higher reliability. And the small gap technology is the best combination of high efficiency, reliability, and cost. So when we use the smart soldering technology, our model efficiency can increase by 0.3% compared to the conventional multi-busbar product. And next page, we cooperate with University of New South Wales and to do some analysis on the tensile stress of the cell for different ribbons from different stage. For example, after soldering, after lamination, or after one thermal cycle, we can find the red one. The red line is the LONGi segment ribbon, and the black one, the white one, is the flat ribbon and the circular ribbon. And we can easily see the tensile stress for over this stage. Our segment ribbon is about 20% lower than all of the other ribbons. That means a higher reliability. Basically, since we have shipped the HAMU 5 actually for about one to 2 months, so this is a manufacturing year data from January, the week 1 to week 4. It's just for 1 month. We can see our HAMU 5 manufacturing yield can be over 99%, and it's very close to 99.5%, which is very similar to our traditional mature HAMU 4 manufacturing yield, simply because we use the smarter soldering technology. And we did some both analysis on our HAMU 540 watts product and compare with the 220 products 595 watts. So I think my conclusion is very similar with Jinko's analysis, because so I will explain why we use the 120 meters racker. Actually, the HAMU 5 is suited for the ultra-large flat scenario. So that means we want to use a longer racker. However, due to the expand with heat and contract with cold theory, the maximum rack length is recommended to be 120 meters. So we did the analysis on this scenario, and we can find HAMU 5 can save both cost about 0.15 cents per watt compared with 220 motors, simply because HAMU 5 can have I think is have 8 strings, and 210 I can only have 6 strings for the 2P fixed mounts. And similarity, when we did the analysis on the one portrait tracker, that means HAMU 5 can also have a longer, bigger strings, which means 4 strings of HAMU 5 and 3 strings for 220. So the HAMU 5 can save both costs about 0.45 cents per watt with this scenario in the Middle East location. And lastly, I will introduce LONGi's reliable bifacial models. Actually, we built, as I mentioned before, we built many pilot projects all over the world. It showed excellent performance. Actually, for different albedo, we can get actually 5% to 25% bifacial gain for different situations. Actually, this is a pilot project built in TV Rhineland, TV CERN, and the ITC. And in last year's ITC High Achiever Award, LONGi is the only manufacturer that has performed well in all 8 indicators in ITCP Model Index report. For example, for the reliability, the ITC did 3 different tests, the DS2000 and the dynamic mechanical loading, PID free. So particularly for the dynamic mechanical loading, LONGi is the only one that passed the test. And for the TV Rhineland yield simulation adult test, where the winner of the TV Rhineland's all quality matters from 2017 to 2020. And also for the PVEL presentation and 2020 bifacial workshop, our model showed the best bifacial gain, which is around 11.44%. So not all bifacial models perform the same. The bifacial gain can vary almost 2% for different suppliers. This is simple, I think, is because the unique no shading design in short side of the frame and the perfect cell technology enables the top performance of our bifacial gain. And also furthermore, in the PV magazine test, the power generation of LONGi model was significantly higher than the others. We can see in the figure, the top 1 and top 2 is all the LONGi's bifacial model. So the last one is quick introduction about LONGi. So we established in 2000, and the revenue in 2019 is 4.76 billion. And the total shipment of bifacial models by 2020 is over 10 gigawatts, and the total shipment of monocrystalline cells and models in 2020 is over 20 gigawatts. And in summary, so high value product means we economic and reliable. This is the 2 core factors, and LONGi insists on providing high value product to customer. So that's all. That's my presentation. Thank you, guys.
Thanks, Jason, for your insights. Very nice. Maybe a few questions from the audience. I think you showed this one slides on the different cell gaps, and you mentioned that you've chosen basically the middle part, so you don't close it completely for various reasons. There's a question also, do you have actually also checked reliability? Is there an issue with breakage? So not only regarding power and such things, but if you compare the one versus the other, so low gap versus zero gap?
Yes, indeed. Actually, I showed one page, the manufacturing year of our HAMO 5. Actually, for only 1 month, the manufacturing year is over 99%. Actually, we compare our HAMO 4 is, I think, is a normal gap technology, and HAMO 5 is, I think, is a small gap technology. So for only 1 month, the manufacturing yield of HAMO 5 is close to HAMO 4. That means it's very reliable. And then, as I mentioned, and I explained we also did some analysis cooperated with University of New South Wales. We found that the tensor stress for a different stage, maybe after sintering, after lamination, after 1 thermal cycle, showed both lower tensor stress, which means high reliable.
Okay. So regarding the number of bus bars, I think someone asked on slide 10, the module with, there was a module with more bus bars that showed more ribbon connector losses. So what are you advocating for? So what's your solution in terms of bus bars?
All right, so our HAMR 5 and HAMR 4 actually use a 9 bus technology. Actually, we have our R&D have did a full evaluation on the different body bus. Actually, for 11 bus or 10 bus for 12 bus, it means more power. However, the cost will goes up. So it's sort of a balance of cost and power, and we do a lot of work. So we determine we use the 9 bus is the best ones. Yeah.
Okay. Maybe one question here also, I think, again, on transparent backsheets, because LONGi is a strong advocate of transparent backsheets. So why are you, can you just simply, for Bifacial, share your experience transparent backsheets versus glass? And what are your plans?
So, yeah, actually, we insist on using bifacial models by using glass. Actually, we didn't use transparent transparent backsheet. Actually, our R&D did a lot of work to analyze the transparent backsheet. However, because our internal test is very severe. It's about 3 times IEC standard. And we found that the transparent backsheet didn't pass the test. That's one reason we didn't apply the transparent backsheet. So for another reason, I think the glass is, in terms of strength, is more powerful than the transparent backsheet. The glass can last for many years. For the transparent backsheet, actually, for the industry, it's very new. I think maybe 2 or 3 years. So we are very cautious about selecting the material. So we choose a reliable glass for the bifacial model. Yeah, okay. That's the point.
Okay, and there's one question: can the HAMR 5 be made with safety glass, or is it available?
I'm sorry, I didn't get a point. What is a safety glass?
I think that's he's probably referring. So if you want to have installations which have building integrated modules directly as an overhead structure, sometimes you need then safety glass. If it falls down, actually it doesn't go into thousands of splinters.
Yeah, absolutely. Yeah, we can use that safety glass. Yeah.
Okay. What else? I think yeah, I think we're still okay in time, but Jason, thanks so much for all your information that you shared with us, and then let's continue.
Okay, thank you. Bye-bye.
Take care. Bye-bye.
Take care.